So, what is the first thing that comes to your mind when you hear the word database? The Wikipedia definition for a database is an organized collection of data generally stored and accessed electronically from a computer system. There are mainly two types of databases: a relational database and NoSQL database. In a relational database, data is stored in tables. A table is like an Excel spreadsheet where each column represents a data attribute or field and each row represents one piece of data. For example, if you have a table holding the employee data, the attribute or fields can be employee first name, last name, and email. So each row resembles a complete piece of data. And we have another table that holds the department data, which can be department name and location. There is a relation between those two tables. For example, a department can have many employees. On the other hand, NoSQL or document databases, instead of rows, they use documents, which is a JSON key value pairs of data that holds, for example, an employee data. And instead of using tables, they used collections, which is a multiple documents stored together. JSON stands for JavaScript Object Notation, which is an open standard file format and data interchange format that uses human readable text to store and transmit data object consisting of attributes value pairs. MongoDB stores data in BSON format, which is a binary JSON. BSON binary structure encode types and length information, which allows it to be parsed much more quickly. There are a number of Python packages used to create and manage MongoDB. We will be using Mongo Engine throughout this course. Mongo Engine is based on PyMongo, which is a lower level package that is used to interact and manage MongoDB. So, in the next lecture, we will begin by installing MongoDB and creating our MongoDB Atlas cluster. Welcome back. In this lecture, we will install MongoDB along with Mongo Campus, and we will create an Atlas cluster. Okay, so let's start by opening the browser and search for MongoDB Atlas. We will click on the first link and we will choose sign up with Google. We will type in our email address and I'll check on I accept terms and conditions and click submit. I'll just follow the wizard. I'll choose that my preferred language is Python. We can skip it and we'll choose continue. I'll choose create a free cluster. You are free to choose AWS, Google Cloud, or Azure, but I'll stick with the defaults and I'll click on create cluster. Our cluster is being created. So let's continue with the wizard. I'll create a user account to access the database. I'll add a new user. I'll just type, for example, Mongo admin, and I'll type a password. And I'll select the role to read and write to any database. I'll just choose add user, and the user is created. The next step is to add IP address to the whitelist, which means that from this IP address I can connect to the cluster, but otherwise I will not be able to connect to the cluster. I'll choose IP address. I'll add the current IP address and click on confirm. The IP address is now being added. Then I'll choose the next step is to load the sample data. I'll click in here and choose load sample data. Again, I'll confirm the selection. The last step is to connect to the cluster. I'll just choose connect. From here, I'll choose Mongo Compass, and I will download the Mongo Compass by clicking on this button. I'll click on close while downloading. Again, I'll open Google. I'll search for download MongoDB. I'll choose this link, MongoDB community download, and I will click on download. Now we have downloaded all the installation files that we need. I'll just close the browser. I'll open Windows Explorer and I'll just double click on MongoDB for Windows, and this will begin the installation process. I'll click next. I'll accept the license agreement. Next. I'll choose complete. Next. I'll untick install Mongo Compass because you have downloaded it, and I prefer to install it manually because sometimes it gets stuck. I'll choose next and install. I'll choose OK. In here, I'll open the environment variable by typing env. I'll choose environment variable. I'll click on the path variable, edit, and then I'll add new. In here, I'll choose browse. I'll go to this PC. I'll choose C, program files, MongoDB, pen and I'll choose OK. Okay. This have included the pen directory in the path variable, which we will choose later. We have finished the installation. I will not reboot now, and I will install Compass also. Compass is being installed. And it's running correctly. I'll just close and reboot the computer. Now we have restarted our computer. I'll just open the command line and I'll type Mongo, and the Mongo client is running and connected to the local Mongo server. The last thing that we will do is to install Mongo engine. To do this, we will use pip install Mongo engine. Now we have installed Mongo Atlas cluster, and we have installed MongoDB server locally along with Compass, and we have installed Mongo engine. This will conclude our lecture. Thank you for watching and join me in the next lecture. Welcome back. In this lecture, we will install Mongo Compass and MongoDB on Ubuntu. The process for creating a Mongo cluster is the same for Windows, Linux, and Mac. So we will not repeat those steps. If you are using Linux or Mac, follow the process that we have used in the Windows section to install a Mongo cluster. To download Mongo Compass, I'll just navigate to this link. I'll put the link in the notes and I will choose Linux. I'll navigate to download and install Compass. I'll copy this link and then I'll open the command prompt. I'll just paste this and this will install Mongo Compass. To run Mongo Compass, you will just run Mongo Compass and it will open Compass. Okay. I'll just close this and I'll click on start using Compass. And it's running correctly. A part of this error, but it's running correctly. To get rid of this error message, you will type sudo apt install -- fix broken, and this will install all necessary modules. To install Mongo DB, I'll just type sudo apt get install MongoDB. I'll choose yes, and this will install MongoDB Community Edition on Linux. After the installation finish, I'll type sudo systemctl enable MongoDB. This will enable the service, and then I'll just type again sudo systemctl start MongoDB to start MongoDB server. I'll type Mongo to check that I am connected, show DBS, and it's working correctly. The last thing that we will do is to install Mongo engine. To do this, we will use pip install Mongo engine. This will conclude our lecture. Thank you for watching, and join me in the next lecture. Welcome back. In the last lecture, we have installed MongoDB locally on this computer. We have installed also MongoDB campus, and we have created a Mongo Atlas cluster. So first, let's open our cluster. MongoDB Atlas cluster is a free servers hosted on MongoDB cloud. We are free to use MongoDB Atlas, or we can use the local server that we have installed on this computer. Let's first begin by navigating to Mongo Atlas, and we will log into our account. I'll click on I am done in here, and this is a message telling us that the sample database have been successfully loaded. We will use it later. Now I want to show you something. I'll just open the command prompt. We have added the pin directly to the path. So when I type Mongo, it will connect automatically to the local server. I'll type show DBS. These are the default databases which are installed by default with the Mongo community server. I'll just exit. Mongo is a command line to interact with the Mongo server. So let's try to connect to our Mongo cluster. I'll choose connect. From here, I'll choose connect with Mongo shell, and I will close this, and I will copy and paste the command line that will allow me to connect to Mongo Atlas cluster. So let's open our command line, and I'll just paste the command in here, and we will press enter. I'll type the password, and it's connecting to the Mongo cluster. It did not connect. So let's check our IP whitelist, which we have created because maybe our IP address had changed. I'll click on add current IP address. Let's confirm. Okay, yes, it had changed. I removed the old one. Now let's try the command line again. Okay, now we are connected to our Mongo Atlas cluster. Let's type show dbs, and these are the default databases created by default, and this is the sample database that we have imported into our Mongo Atlas cluster. One more thing to do. Let's open our Mongo Campus. Mongo Campus is a GUI interface that will allow us to interact with our Mongo database, whether the local one or the Mongo Atlas cluster. If I did not type anything in here, it will by default connect to the local server. So I'll just connect. Now we are connected to our local server. These are the install databases by default. I'll close the old window and let's connect to our Mongo Atlas cluster. To connect to the cluster, I'll click on connect using Mongo Campus, and I'll just copy and paste this. I'll paste it in here. All I need to do is to change the password, and I'll click on connect. And it had connected successfully to our Mongo Atlas cluster. We will be using both the local installation and the Mongo Atlas cluster throughout this course. This will conclude our lecture. Thank you for watching and join me in the next lecture. Welcome back. In this lecture, we will take a quick tour on the Mongo command line. To do this, I'll open command prompt, and I'll also open the Mongo Campus. To connect to the local database, I'll type Mongo, enter, and now I am connected to the local database. And I'll also connect to the local database using Mongo Campus. Now let's try to create a new database. So I'll type show dbs. To create a new database, I'll type use students. This had created a new database called students. If I refreshed here, nothing had been created because I did not create any records yet. To create a record, I'll type db, then collection name. I'll create a collection called courses. Then I'll type insert 1. I'll open curly braces. I'll create a field named course name. between double quotes, and the value for this course name will be, for example, history, and I'll close the curly braces and the parentheses. Let's press enter, and this is what printed on the screen. Acknowledge true. This means that the record created and with an ID of this value. Now let's check our Mongo campus. Notice that we have here a new database with a collection called courses. When I click on courses, I'll find the record that I have created. MongoDB creates the underscore ID field automatically. We will see later how to create this from a certain field, but if I did not specify an ID field, MongoDB will create it automatically. Okay. Now let's query this. I'll use db courses dot find. Find will return all the records in the collection. To update a record, we can use db courses dot update. And by the way, the command line have an autocomplete, so you can just type the beginning characters of the command, and then pressing tab will complete the command. Now we have to type the search criteria. This should be course name, which is equal to history, comma, we will use set course name set curly braces course name equals math. Now acknowledge equals true. Matched, this means that our query had matched one record. Modified count is 1. Now let's check campus, and the course name had changed it to math. Now let's delete this record. I'll use delete 1, and I'll give it the same condition as the update. I can just take this and paste it. And it had deleted the record. Of course, this have nothing to do with Python, but I wanted to show you that we can use the command line to create records either on the local MongoDB server installed on this computer or on the Mongo Atlas cluster that is running on the cloud. So this will conclude our lecture. Thank you for watching and join me in the next lecture. Welcome back. In this lecture, we will learn how to work with Mongo Compass. We have installed Mongo Compass in a previous lecture. To launch it, you can use Start Mongo Compass, or you can just double click on the icon on the desktop. Similarly, in Mac and Linux, you will find an icon for Mongo Compass. When you launch it, it will load the plugins and it will launch this screen waiting for us either to connect to the local database, or we can just copy and paste the connection string for a remote server. For example, when we connect to Atlas. Okay, so let's connect to the local database and explore it a little bit. On the left side, we'll find the recent connection and when we have connected to it. Later in this course, we will find how we can connect to database with authentication. Okay, now let's connect to the local database. I'll just click on connect and it will connect to the local database. And we will see later how we can connect to our Mongo Atlas cluster. Now we are connected to the database. On the left side, we will see the local default databases, and on the right side, we will find some details for the local database. So let's create a database. I'll just create a database called testDB, and I can create a collection named employees, for example. I'm just creating a database so we can see on the right side other options have appeared now. Okay, I can insert data directly from here. Okay, this will allow me to insert a document. The document is simply a JSON object, but we will not use Compass for creating documents, but we will just use Compass for visualizing the data, as we will see later in this course. This tab contains the documents. Now, to visualize the data, let's connect to our Atlas cluster since it have more data, and let's check how we will be using Mongo Compass. So to connect to our cluster, I will just click on connect to. I'll close this window and let's get our connection string from Atlas. I'll just log into our Atlas cluster. To be able to connect to the Atlas cluster, I will just click on connect and I'll use connect using Mongo Compass. I'll click on I have Mongo Compass and I'll copy this string. Okay, but before we can connect, we will go to the network access tab and I'll make sure to add the IP address. I'll add the current IP address and click confirm. I'll remove the old one. Of course, you can allow access from anywhere, but this is not recommended. Okay. Now in here, I'll just paste the string we have copied. I will change the password and I'll press enter, and we are connected to our Mongo Atlas cluster. Now let's check some of the sample databases that we have installed. I'll go to sample mflex, for example, and on the left side we will find the databases that this server contains. On the right side we will find some details. For example, the sample mflex database. Size for this database is around 40 meg. It has 6 collection and 11 indices. Later in this course, we will investigate what's meant by this. These are the current collections. Okay, I will just click on movies, and this is a sample document. Okay, we are in the documents tab. We can view the documents as document. This is the default view, and we can switch to JSON view, something like this, or we can view it as a tabular form. Okay, let's switch back to the default view. You can query documents from here. The syntax to query the object is based on JavaScript language. I can use this to export the collection, add new data, or import a JSON file. Okay, we will not use Compass this way, rather to view the changes that we have made in the document. In the aggregation tab, we will learn later about the MongoDB aggregation framework, which is used to aggregate the documents. Later, we will check the schema tab and the explain plan for the query, the indices tab, and if we want to add validation rules. During this course, we will learn how to use Mongo Compass, but right now we will use it to look at how our collection and documents is created. Okay, this was a quick lecture on how to use Mongo Compass. Later in this course, we will learn more details about Mongo Compass. This will conclude our lecture. Thank you for watching, and join me in the next lecture. Welcome back. In this lecture, we'll explore how to interact with MongoDB with Python. To begin, I'll just open the command line and I'll open Jupyter Lab or Jupyter Notebook. I will create a new folder. I'll call it Notebooks. And let's start by creating our first notebook. And I will rename it Connecting to Database. Before we can explore MongoDB, we will have to connect to the database. So from Mongo engine, import connect and disconnect. If I type connect without any parameters, it will just connect to the local server on this computer. Connect takes a few parameters. So if I press Shift Tab, the first parameter is the DB. The alias is by default called default. So if I just type the name of a new database in here, like project 1, and press enter, it will give me an error that I have already used an alias called a default. When I connected in here, the default alias is default. Since I did not specify a new alias with this connection, it just gave me an error. So to start connecting to the database, I'll have to disconnect. And then now if I used connect and typed project 1, it will work this time. Let's assign this to a variable called connection. Now let's check the connection dot address. This is referring to the local host, which means this computer, and the default port for MongoDB is 27017. Okay, so let's check some of the properties. We can use list db names, and this will list all the databases on this server. We can also get the server info. For example, we will use connection.server info, and it will give us a lot of details about the servers that we are currently connected in. The version of the server, if any modules installed, the environment for the server, which is Windows, and it's 64-bit, etc. Now let's disconnect and connect again with other parameters. I can connect and type in the host. For example, if it's the local computer, it will be 127.0.0.1, and I can specify a port if I want. We saw that the default port is 27017, and we have established a connection. Let's disconnect and let's connect again to, let's find the IP address for this computer. I'll click on Network and Sharing Center, and this will open the properties for the card. Now we know that the IP address is 50.192.168.50.31. We can connect directly to this IP. So I'll connect to host 192.168.50.31, and I'll specify the port, or we can just connect to the default port. Okay, now let's disconnect. We can also connect to the server using a URI string. The URI string is something like this. I just type host and I'll use Mongo. We will see this later in this lecture. I'll just type local host, and it had connected to our locally installed server using the URI. But let's say that I want to connect to our Atlas cluster that we have created. So let's open our MongoDB Atlas site. To get the URI string, I'll just click on connect. I'll choose connect your application. In here, I'll choose Python as the driver. and I'll choose version 3.11 or later, and I'll just copy this connection string or the URI. I return to the notebook and I'll connect. Let's first disconnect. Now let's assign Atlas, which will equal to connect, and we will have to type in the host, and then let's paste the string and change the password in here. And we have connected to the Mongo Atlas cluster. Atlas.address, and this is the address for the cluster and the port that we have connected to. Let's check the databases that we have on the server, and it will retrieve the sample databases along with the default databases that already exist. Okay, now we have connected to the locally installed MongoDB server and to the Atlas cluster. This will conclude our lecture. Thank you for watching and join me in the next lecture. Welcome back. In this lecture, we will explore what the CRUD operations are, and we will continue to work with them throughout this course. CRUD stands for create, read, update, delete. Any application that you will create that interact with a database, it will need those operations to save your data, query, update, and delete records. So let's start by the create operation. I'll just import from Mongo engine import asterisk, and then I'll connect to the local database, and let's start by the create operation. This is just HTML formatting for the cells. I'll create class contact. This will inherit from document. We will get into the details of all these things on the upcoming lectures, but I won't show you all the CRUD operations in this lecture. To create a field, I'll create a field called first name, which will be string field. Last name, which will be again string field. Email, this will be an email field. And finally, phone, this will be again string field. Now we can create a collection based on these attributes. So let's create contact 1, which will be an instance of contact. I'll just give it a first name, which will equal to Tom, for example. Last name, this will equal to Freddy. Email, t.freddy@gmail.com. And phone. Let's click enter. Now let's open our Mongo campus and check. Nothing had been created. And this is because before creating anything, we will have to save. This means that it has created this document. So let's check our Mongo campus again. We will notice that there is a database in here called test. We haven't created this one, but since we haven't specified a database, MongoDB automatically create this database for us, and we have created a collection called contact. This is based on the name of this class that we have used, and this is the data that we have specified. Okay, now that we have created a record, let's query it. So we will use the second letter in the CRUD operation, which is read. Let's copy this and paste it in here and change this to read. So let's declare contact2, which will equal to contact.objects first name starts with, for example, T. Now let's check contact2 dot first name. It will return Tom. Now let's check the third character of the CRUD operation, which is update. Now let's create contact3, for example, which will equal to the same syntax that we have used here. And I retrieve the first item, then contact3 dot first name. I'll update it to John, for example, and let's save contact3, and it had updated the record. Let's refresh, and it had correctly updated the record. And finally, let's check the last letter in the CRUD operation, which is delete. So let's use the delete command. I'll just use contact3 dot delete, and let's check the campus, and it had deleted the record. These are the 4 letters of the CRUD operation. Throughout this course, we'll explore each and every one of those. Okay, so this will conclude our lecture. Thank you for watching and join me in the next lecture. Welcome back. In this lecture, we'll explore how to create documents. Let's start by importing everything from Mongo Engine. From Mongo Engine, import Astro. And let's connect to our local server and let's create a collection. To create a collection, we will create a class that inherits from the document. I'll create first name, which will be string field. Last name will be again string field. Email, which will be an email field. And now let's create a record. I'll create contact 1, which will be contact dot first name equal, for example, Tom. Last name will equal to Harry, and email will equal to t.harry@gmail.com. Now, as we have seen earlier, this will not create anything. I'll need to save the document first. To save it, I'll just use the save method. Seems we have mistyping here. This should be contact 1, and this again should be contact 1. Now let's check campus, and by default, since we have not specified a database, MongoDB had created this database for us, and it have created this collection based on the name that we have assigned here, contacts and contacts. Okay, but what if I want this to be stored in something? What if I wanted to specify where the database is stored? So let's drop this database and let's disconnect, and we will specify the database in here. Now let's connect again and specify the database with the DB argument. I'll just create a new database called test DB, and this means that any object I will be creating will be placed on this database. I'll just copy and paste this. And now let's use the save attribute and let's refresh. Had created this database and had created a collection named contacts, and the record is stored in here. Okay, but what if I don't like the default collection name? So to specify a collection, we will have to specify it when creating the class. So let's copy this, and there is a special keyword called meta And meta takes a dictionary. We'll explore meta later with more details, and I will specify the collection, which will be the new collection name. I'll give it my contacts, for example. Now let's copy again those two fields. Let's execute this one and this one. Now let's check Compass. Let's refresh. It had created my contacts and it had created the record on it. Okay. So this will conclude our lecture. Thank you for watching and join me in the next lecture. Welcome back. In this lecture, we'll explore fields. A document can have different type of fields. This is the Mongo engine documentation. You will find that there are lots of fields. We will use quite some of them throughout this course, but here is the complete reference for all the fields that you can use with Mongo engine. So let's start by creating a new collection. I'll name it employee that will inherit from documents. I will create a field called employee ID. Until now, we have used MongoDB to create our ID field, which creates it automatically. So this field, we haven't declared it yet. MongoDB, if you have not specified a primary key, it will automatically create underscore ID field. Okay, so let's this time create a long field that will be primary key for this collection. Primary key equals true will make this field the primary key for this collection. I'll again create first name. This will be string field. Last name will again be string field. Email will equal to email field. Birth date will be a date field, and similarly it can be a date time field. Salary will be a decimal field. We're trying to use some of the field that we have seen. And by default, when we create this, it will be created in a collection called employee. Okay, so I'll declare emp1 will equal to employee. I can just type the value in here, or I'll just create an instance of the employee class, and then we can assign it emp1.empid. I'll assign it 1, 1, 2, 3, 3, for example, and emp1.firstName will be Harry. emp1.lastName will equal to Grant. emp1.email equal to rich.grant@yahoo.com. emp1.birth date, and I think we have a spelling mistake in here we should adjust this to birth date. It's again, and it will be birth date. In here I'll assign a string, and let's see how it will work. And employee1 dot salary will equal to 10,000. Now we can save this. Let's check campus, and in here, since we are using the same database, it have created this document. As you can see, the birth date has been converted to a date time field automatically, although it was string. We have passed a string in here, but we have created the document with a date time field, so Mongo engine had automatically converted the string to a date time field. Now the underscore ID have been assigned the value as we instructed it. So let's create another employee. emp2 will equal to employee, and I'll pass the emp ID, which will equal this time 1, 2, 3, 4, 5. Of course, you can create an ID as we have done in here, or you can let MongoDB create the ID by itself, and I prefer that MongoDB create the ID because it needs to be unique. If you have a specific application and you want to create the ID yourself, then it's fine. Last name will equal to Hardy, for example, or Harry. Email will be j.harry@hotmail.com, and birth date again will be string, and salary will be 11,000. emp2.save, and it had saved the document. Now if we refresh, we have two documents, each with its own ID and with its own detail. Okay, so this will conclude our lecture. Thank you for watching, and join me in the next lecture. Welcome back. In this lecture, we'll explore the field's parameters. Last lecture, we have created this employee collection. We will use the same class, and this time each type of field have different parameters. For example, the string field have a maximum length and a minimum length. For example, let's give it a maximum length of 64 characters, and there is also another argument called required. Required, when set to true, means that this field needs to have a value in order to save the document. Otherwise, it will not be saved. Again, I'll type a maximum length of 64 characters, and required will equal to true. Email field will be required again, and we will use another argument called unique. Unique means that this field should not be repeated among the collection. Date time field and the salary. Now let's create a new employee. I'll just give this another number. This will be John Hardy, and I'll save this. It worked. Now let's create another one with the same details. Now let's give it another ID. Let's save EMP2, and this will generate an error. The error say duplicate key error. Let's check at the bottom. Try to save duplicate keys, duplicate key error collection, the collection name, and this is the duplicate key. Because we have declared the email as a unique, so it will prompt us for error when it is repeated. Okay, so if we change the email to another value, for example J2, it will work. Let's try to create an employee without passing a first name. It will give us an error because the first name is not declared. Why it prompts us for this? Because we have declared it with required equals true. This is how Mongo engine validates the field. Required and unique are some of the parameters that are used to validate the data. Now let's check another example. I'll just type this is test emp2.save, and again it had created a validation error because this is an invalid email. Since we have declared email with an email field, so the email field automatically validates its content, and since this is not an acceptable email address, that's why it prompted us for an error. So this will conclude our lecture. Thank you for watching, and join me in the next lecture. Welcome back. Last lecture we have seen the fields parameter, and we have seen the default built-in validation for Mongo engine. For example, if we defined a field equals required and we did not enter a value for this field, it will generate an error. Or if we declared a field with unique parameter and we repeated the value, it will also generate an error. So what if I wanted to create a custom validation. So let's check how we can do this. I'll import from date time, import date time. I will create a function called checkDate. This function will take single parameter, be date for per date. I'll declare variable delta, which will equal to date time dot today minus date time dot string parse time. This will take the parse date and it will convert it from this format. This format means that day followed by month followed by year, and day and month are represented in 2 digits, while year with capital Y is represented in 4 digits. It will then check if delta dot days divided by 365, which will calculate the number of years, is greater than 30, then we will raise validation error to old. Okay, now let's copy the employee class from the previous. I'll just copy this. Let's paste it in here. I'll just remove this, we don't need it. I will not create an ID field, I'll just work with the auto-generated one. In the per date, I will just say that validation equals, and I will use the previous function. I will also declare meta variable, and I'll generate those documents in another collection called emp2. Okay, now let's create an employee. First name will equal to John, last name will equal to Harry, email j.harry@gmail.com, birth date will equal to, let's give it 31 January 1970, and finally salary will equal to $10. Okay, let's go through the whole process once more. I have declared validation will equal to this function, so this means that the per day will be validated through this function. This function takes the per date defined here and it will convert it to a date using string parse time, which take the per date in this format, 2 digits for the day, 2 digits for the month, and 4 digits for the year. If the date entered is not following this format, it will generate an error. It has to be exactly in this format. It will subtract, we have a typo in here, it will subtract this value from today's date, and it will divide this value. This is also a typo, this should be days. It will divide this value by 365, which means that we will convert it to years. If this value is greater than 30, we will raise a validation error. Let's execute this again. Okay, now let's execute this emp1.save, and it has generated the error. Okay, let's copy this, paste them in here, and we will make this 2000, for example, and it should work correctly. Let's check this. This is the collection that we have created, and the record is stored in here. This is great. So this is how we can make a custom validation. Okay, now let's check a couple of more keywords with the fields. If I wanted to give a default value to a field, I'll just copy both of them and just paste it in here. I'll just remove this, and let's say that I will define a new field called employment date. I can give it a default value with default keyword. This can be, for example, date time dot today. This means that this field will be filled in with today's value. Let's check this. We have a typo in here. This should be date field. Let's change this email because the email is unique. Let's save the record and let's check the collection. Now the employment date will be set to today's value. Okay, we haven't even entered a value in here. It will always be today's date. Okay, I can also create a compound unique record. For example, let's copy and paste this, and I will just remove this one, or we can leave it. It will not make a difference, but let's say that I will create the last name unique with first name. So this means that both fields will be combined to create a unique record. So first name and last name should not be repeated to create a record. Let's check this. If I try to enter something that already exists, and you will see this error message. Now let's change this a little bit. I'll just copy and paste, and let's change this to John 2, for example, and save. Let's check our collection. Oh, because this collection now have two John Harry, I'll delete this one. Again, let's save this, and it worked. If I change this, because the email is not changed, so let's change this. You will notice that Mongo engine displayed an error message, although we have removed the uniqueness constraint. We will see this later because behind the scene, Mongo engine create an index for whatever we ask it to be unique. For example, in here it had created a uniqueness constraint for the email. Okay, if we remove this, it will not bother us again. Okay, so Let's again copy and paste this. I'll this time make this 2 and this John 2 and Harry 2. Let's check this, and it worked even with the repeated email. Okay, this will conclude our lecture. Thank you for watching, and join me in the next lecture. Welcome back. Although this is a document database and not a relational database, this doesn't mean that we cannot create relations between different collections. In this lecture, we will explore the different types of relationships between different collections. There are basically 3 types of relationships between different collections. First type is one-to-one. In a one-to-one relationship, only one record is associated with only one record. For example, a collection called employee. Each employee have only one address. So, in document databases, we group the one-to-one relationship in the same collection. The next type of relationship is one-to-many. In one-to-many relationship, one record in a collection is associated with one or more records in another collection. For example, this is a collection called book. A book can have a multiple reviews. We can embed the reviews as an embedded document, as we will see later. We can embed the reviews in the book collection, and this is called embedding, or we can create a separate collection for the reviews, and we can reference them by using their ID, for example, and this is called referencing. The last type of document relationship is called many-to-many, in which multiple records in a collection are associated with multiple records in a different collections. For example, the authors and the books. The book can be created by multiple authors, and multiple authors can create multiple books. Okay, so let's fire up our Jupyter notebook and start creating relationships. Welcome back. So let's explore how we can create relationship between collections. First, from Mongo engine import asterisk, and we will connect to the local database. Let's start by creating a one-to-one relationship. So let's create class address, which will inherit from embedded document. It will have city, this will be string field, zip code, again string field, street, string field, and house number, this will be an int field. Then let's create class employee, which will inherit from document. It will have first name, this will be string field, last name, this will be string field, email, this will be an email field, and address, which will be an embedded document field. The embedded document field will need an embedded document, which we have already created. This is the address. Now let's create address 1, which will be instance of address, city, for example, New York. Zip code will be street, Chinatown, and house number will equal to 10. Embedded document doesn't have a save method because they will be saved along with the parent of this embedded document. So we will create employee 1, which will be an instance of employee. First name will be John, last name will be Mark, email will be j.mark@gmail.com, and finally address will point to address 1. Now let's save emp1, and it had been saved correctly. Let's refresh this, and we can find here employee collection that have an embedded document, and here is our document which have an embedded document for the address. Okay, so we can also create it like this. I just saved it Jim, Harry, and in here I can directly create an instance of address, city, for example, Los Angeles. Zip code will equal to 912. Street, downtown Bunker Hill, and house number 15. Let's save this. Let's check campus, refresh, and this is the second record that we have just created. Okay, this is called one-to-one because there is only one address associated with the employee. An employee cannot have two addresses. Similarly, the credit card number, the ID number, etc. So let's check the one-to-many relationship. A one-to-many relationship is when a document is associated with one or more documents in another collection. So let's create class book. This will be an embedded document. The book will have a title. This will be string field. It will have pages, which will be an int field, and it will have a price, and this will be float field. Okay, now let's create a publisher. This will inherit from document. First name will be string field, last name will be string field, email will be an email field. A publisher can publish one or more book, but a book will be only published by one publisher, and this is an example of a one-to-many relationship. So let's declare books. Books will be a list field of an embedded document field which will point to book. Okay, now let's create a couple of books. I will create book 1. This will be an instance of book. Title, the maze, pages 200 for example, and price will be 29.99. I will just copy and paste a couple of times, and this will be book 3. Let's say that this is the maze 2 and 3. Of course, this can be similar or change it, it will not make any difference. Now we have created a couple of books. As we mentioned earlier, embedded documents does not have a save method. Now let's create our publisher. I will create publisher 1. This will be an instance of publisher. It will have first name Tim, last name will be John, email will be t.john@yahoo.com, and now we have to, and now the books field. The books is a list of embedded documents, so this will be a list of book 1, book 2, book 3. Now let's save the publisher, save, and let's check campus. Let's refresh, and here is our publisher. It have an array of objects. Each object is a book, and this is a typical example of the one-to-many relationship. This is called embedding because we will embed a document in another document. Now let's check another type, which is referencing. I will just copy and paste the whole example, and I will modify it. Instead of embedded document, I will just inherit from document, and in here this will be a reference field instead of an embedded document field. I will also create this in another collection, so I will declare meta, and in here I will type collection publisher 2. Now let's execute this. This time I will have to save the books because they will have their own collection. Book 1, not save, book 2 and book 3, okay, and publisher 1 also. Now let's check this. We will have the book collection that had been newly created, and we have publisher 2. Publisher 2 will have an array of references to the books. This is similar to this method where we have embedded, but this is called embedding and this is called referencing. In this example, if there is a way to tell who's the publisher for book 1 by querying book 1, this is impossible. So let's modify this to allow us to answer the question who published book 1, for example. I'll just copy all this and let's modify it, but this time I will add another field called publisher, which will be a reference field to publisher, and I will just add this quotation because the publisher definition will come later. This will be a reference field for the publisher collection. I'll name it publisher COL, and this will be publisher COL, for example, and I will create this in collection book 3, and this will be in publisher 3. Now let's execute this. Now we have created the collections. I will just create the publisher first, because if I created the books first, I will need to modify 3 books. Now let's remove this, and this should be publisher COL, and in here this will be publisher 1. I'll just copy and paste this. Now let's execute this, and the next step is to add the book to the publisher, and this is a bidirectional referencing for both book and publisher. This will allow us to get the published book for publisher and to get who published each book. So I will just type publisher 1.books. This will equal to book 1, book 2, book 3, publisher 1.save. Now let's check the newly created collections. This is book 3, the collection that we have created. As you can see, they are pointing to the same publisher ID, and publisher 3 will have an array of references for the book. And now, to answer the question, who created this book, you can simply query the book collection to get their publisher. For example, you can just type book1.publisher.firstname, and this will type the first name for the publisher. Okay. Now let's check the last relationship, which is a many-to-many relationship. I'll just copy those, paste them in here, and let's modify them. Instead of publisher, I'll use author, and this will be list field of reference field, because this is many-to-many relationship. This will be author, and this will be author 4. Okay, this will be authors. An author can create multiple books, and a book can be created by multiple authors. So this is a typical many-to-many relationship. So what we have done is we have created a list field that contain a reference field to the author, and in the authors we have created a list field for a reference field for the book. So now let's create some data. I'll just copy and paste this, and we will modify it. So let's execute this. This will be author. I remove the books for now, and I'll create a second author, Tom Jack. Of course, since I haven't created any validation, if I left the data as it is, it will work, but it's better to have different data so we can check it on campus. Okay, now we have created the books and the authors. Let's check this. This is the authors. At the moment it have an empty books array, and this is the book, which at the moment have an authors empty array. Now let's create book 1 dot authors will equal to author 1, author 2, for example. Book 2 dot authors will only have author 1, and book 3 dot authors will only have author 2. Okay, let's copy and paste this, and of course you can execute copy and paste by pressing C and V. Okay, let's check campus. Now books are populated with the reference to the authors collect. Okay, let's do the same thing for the author. So authors, author 1 dot books. Author 1 have created book 1 and book 2, so this will be book 1 and book 2, author 1 dot save. Let's also create author 2 dot books. This is in book 1 and book 3. Okay, now let's check campus. Let's check author 4. Now each author have couple of books that he had created. Great. So from either side of the collection you can query the other end. What I mean by this is from book 1 dot author, this is a query set because it's having multiple authors, so to reference the first one I'll use authors. Either I can just use an index like this, 0 or 1 dot first name, for example, and from the other end I can, for example, for book in author 1 dot books print book dot title, and it have printed the titles for the book. One question may arise: what if I deleted a book or a publisher? What should MongoDB do? This is called referential integrity in a relational database world. Let's check how this works. Before we start, let's drop the test database. So we have a clear state, and I'll create a couple of classes, books and publisher, for simplicity. Let's take this one, for example, and I'll just paste them. I will create the publisher first, and I'll just remove the list of books from here and put it on the other end. And this way it will be more obvious. And in here I will create a publisher. This will be a reference field of publisher. This is a one-to-one relationship, but it will not make a difference. I'm using it only for simplicity. So I'll make collection book 1. Now let's execute this, and let's create a publisher and a book. I'll just copy these, paste them in here. This is our publisher and this is our book. Now let's save book 1. I'll just copy and paste this, for example. This should be publisher. I'll execute this, and I will execute this and save book 1. Okay, now let's check compass, and we have publisher 1 and book 1, which is pointing to the publisher. Now the question is, what if I deleted the publisher? What do you think MongoDB should do? So let's delete publisher 1. Let's check compass. Book 1 data is not intact. Let's check publisher 1. The question is, now book 1 refers to a non-existing publisher. If this is the result that you want, then this is okay. But you can handle this totally different. Let's check how can we handle this situation. I'll just again copy and paste this. There are multiple options that we can use that will create a different result. For example, I'll just create again the publisher and the book, and in here I'll create it in collection 2, and in here we have an option called reverse delete rule. There are multiple options. The first one that we will check is deny. Now let's execute this. I will create publisher 1 and book 1. Now let's check compass. We have now book 2 and publisher 2. Okay. Now if we try to delete publisher 1, it will generate an error message because publisher 1 is still referenced. So book.publisher refers to it, means that publisher 1 is still in use, so you cannot delete it. This is the first way to handle this type of situation. Let's check another option. Again, I'll just copy and paste the whole thing and let's modify it. This time I'll use collection 3, book 3. This time I'll change the rule to nullify. Let's check what will this do. Again, I'll create the publisher and the book, and let's check compass first. Again, book 3 is referring to the publisher, and publisher 3 exists. So let's execute this. It didn't generate an error this time. Let's check publisher 3. It's empty. It deleted the record. Let's check book 3, and it have removed the entire field. This is what nullify does. Okay. So let's check another case. I'll just copy again and paste. I'll just again copy and paste all of these. Again, this will be collection 4. This will be collection 4 also. The next case is cascade. Now let's execute this. Let's check Compass. This is book 4 and this is publisher 4. If we now execute this, let's check publisher 4, it's empty. Let's check book 4, it's empty. Cascade will delete all related records for the document that had been deleted. So if we deleted a publisher, all records associated with this publisher will be deleted. The last option is a little different because it works with array. Let's check this. I'll just again copy and paste all of these. This time we will not use publisher, we will use author. I'll just name this author 5 since this will be book 5, and this will be author, and this will be list field of reference field. This time it will not be cascade, it will be pull. Okay, now let's create a couple of authors. Let's first execute these two. I'll copy both of these, author 1 and author 2. This will be Tom Jack, t.jack. Now let's execute this. Now let's create a couple of books. This will be author, and since this is a list, I'll create author 1, author 2. Let's copy and paste this a couple of times. This will be 2, this will be 3. Let's say that this will be author 1 and this will be author 2. Alright, now let's execute this to create our books. This is a typo, this should be author. Let's execute this again. The authors already had been created, but let's rerun this. Okay, before we delete author 1, let's check our Compass and look for author 5 and book 5. Author 5 will contain 2 authors. Book 5 will contain the 3 books that we have created. 2 of them are being created by author 1. Now let's delete author 1. Let's refresh, and this is what pull will do. Pull have removed the reference for author 1 from the books. So this array did have both author 1 and author 2. Now it only contains author 2. This array have only author 1, it have been removed, and this one with author 2, it was intact. Now this have only author 2. Okay, and this is referential integrity. Welcome back. In this lecture we'll explore indexing. The Wikipedia definition of an index is a data structure that improves the speed of data retrieval operations at the cost of additional writes and storage space. So in plain word, let's imagine that we have a collection like this. It has the first name, last name, and age attributes. What if we wanted to search by the first name? Let's first put the collection in a tabular format. The first name field is not sorted. So to search for a specific name, we will have to examine the entire documents in the collection to return a certain name. So what if we sliced the database and took the first name field and sorted either ascending or descending, and this slice is called index. In this index we will sort the first name ascending or descending, and it will have a pointer for each field in the entire collection. This will improve the speed of search at the cost of additional write, because when we add or update new records, the index will have to be updated. Similarly, we can create an index for the last name and the age. When we create more indices, we will again improve the speed of data retrieval, but when we insert new records or update the existing ones, it will take much more time, because we will need to update all of the indices that are created. To create an index, let's create class book. Instead of creating, I'll just copy this from the previous code and let's paste it in here. I'll just remove all of this and let's check the books. I'll just modify this and I'll create meta collection book 6. Now let's create this and I'll create a couple of books. I haven't created an index. I just want to show you something first. This should be 2b. Of course, as we said, if we left the information without any modification, it will not make any difference. Now let's check book 6, this collection. If we clicked on indices in here, by default an index is created for the underscore ID, and this type of index is called unique. Okay, now let's check. What if we try to search for something? We will deeply into querying document later, but let's search for the book that have title equal the maze. This is how we search for book, but I'll use a method called explain. Let's execute this and you will find in here winning plan stage collection scan. This means that when we were searching for a book with title the maze, we have scanned all the documents in the collection, whether this was a small number of documents or the full documents. Of course, this will take some time. So now let's check how we can create an index. I'll just copy and paste all of these. I will paste them in here. I'll create a new collection. To create an index while creating the collection, you can just in the meta type indices, this will be a list, and define the indices that you want to create. For example, I'll create an index for the title. I will create a compound index for both pages and prices. By default, the index will be created in ascending manner. To reverse, you can use minus or hyphen before the field name. So prices will be sorted descending. Now let's there is a typo, there should be a comma in here. Again, there is a typo, this should be price. I'll execute this. Now let's create our records. Let's save. Let's check Compass. Here is book 7. These are the records that we have created. Let's look at indices. Now we have the default index that had been created while creating the collection. This is of type unique. The pages and the price are compound index. So this means that we can search by both of them at the same time or either one of them. And the title is a normal index. Okay. If you notice, the underscore 1 after the field name means that this is ascending. Underscore -1 means that this is descending. You can also notice the arrows in there. This means ascending, this means descending. Okay. Now let's again execute this. Since now we have an index in place, by default MongoDB will use the index to scan the collection. This will be much faster. So as you can see, the winning plan, stage fetch, and stage ix scan, which mean that index scan. Okay, indices will make your queries run faster on the cost of more time while saving or updating documents, because if you have multiple index created, when you insert a new record or update an old record, MongoDB will have to update all the indices. Okay, so what if we have created the document but forgot to create an index? Okay, so how can we create the index at later stage? So let's delete those indexes. We can delete them from here. Click on this, we'll delete the index. So let's delete them, drop, and this one is called pages underscore 1 underscore price underscore -1. Let's drop. Both indices have been deleted. To create an index, you will use book.create index, and this, when we create the title, this means that this is ascending. What if we wanted to create the other compound index that we have seen? We can create it simply by passing a list. The list will contain pages and minus price. Let's execute this, and this is the same exact thing that we have seen before. Let's refresh, and these are both indices that we have created. Now let's again rerun this, and you will see no difference. Again, it's using the indices to search for the documents. Okay, what if we wanted to drop the index? To drop the index, we will get the collection, which use book. There is a method called underscore get collection, and we can use collection dot drop index, and I will pass the index name, not the field name. The index name was title underscore 1, as you can see it in here. If we executed this, now let's check Compass, and it had been removed. Okay, this will conclude our lecture. Thank you for watching, and join me in the next lecture. Welcome back. In this lecture, we'll continue with the CRUD operation. Last lecture, we have seen how to create documents. This lecture, which will be a fairly short lecture, we will see how to add documents. So let's start by importing from engine import asterisk. I'll connect to the local database with the default connection. Let's create class contact, which will inherit from document. It will have first name will be string field, last name again string field, email will be an email field, and phone, which will be string field again. Okay, now let's create contact 1, which will be contact first name equals Jack, last name will be Hardy, for example. Email will be j.hardy@yahoo.com. Phone will be 065, any number. Now we have a typo in here. This should be a string field. Now let's save contact 1 dot save, and we have created contact 1. Now let's check campus, and since we haven't specified a database, so the collections will be created in the test database, and this is the record that we have created. Okay, we have seen this before and nothing is new, but let's create another record. I'll just copy these and let's adjust something in the save. The save parameters have something called write concern, and by default it's none. Write concern describes the level of acknowledgement requested from MongoDB for write operation to either standalone MongoDB or replica set. If you remember, we have created 2 servers to work with MongoDB. We have created a local one and we have a cluster which is hosted on the Mongo cloud. The cluster have 3 servers connected together, and the cluster hosts all the data. So the write concern requests acknowledgement for more than 1 server in a cluster. So if I type write concern and it takes a dictionary, inside the dictionary you will type W, which means write, and you type 2, which means that I want an acknowledgement from 2 servers before you return to me. Now when we try to use write concern equals 2, it will give us an error message because we cannot use W greater than 1 when a host is not replicated. Okay? So to be able to use write concern, we will connect to our cluster. So I'll just disconnect and reconnect again to our Mongo, and I'll open the Mongo Atlas. I'll click on connect your application. I'll copy this. I'll just type here host equals, I'll just change the password And if you are not connected for some reason, you can check the network access and make sure you put your IP in here from add IP address. Now let's again copy and paste this. Okay. Now let's create this collection, and I'll save with write concern equals w2, and it worked. So we have seen how we can write to multiple servers at the same time. Now let's check how we can save multiple documents at once. I'll just disconnect. I'll remove this from the test database. Let's connect to the local server. I'll again create the document class. I'll just create contacts which will equal to a list for I in range of 10 or 100, for example. I'll just copy this, paste it in here. I'll remove this one. I'll just append the string representation of the loop index, so it will create, and we will see this how to do this in a professional manner later in this course. I'll just append this to contacts list, and now we can just use contact.objects.insert contacts, and it will insert all the 100 objects at the same time. Let's check, and as you can see, it have created 100 objects, as you can see in here. Okay, and of course you can just suppress this output by putting a semicolon after the command. I'll just delete the contact collections again. Let's execute this. I'll again execute this one, this one, this one, and this one, and let's check in here, and it had created the same 100 records, but it did not print all of these objects. Okay, so this will conclude our lecture. Thank you for watching, and join me in the next lecture. Welcome back. In this lecture we will learn how to query MongoDB. So let's start by importing from Mongo engine import asterisk, and this time we will not connect to the local database, but we will connect to the Mongo cluster. So let's check. First, let's get the connection string. I'll connect from my application. I'll just copy, and in here I'll use connect host will equals to, I'll type in the password, and I will remove this database, and I will choose sample m flex. Let's also connect using Compass to explore the mflex database. So I can just type the username and password in here. I'll just confirm, or I can find it in the history. So I'll just paste this and type in the password, and I'll click on connect. Now I'm connected, and here I'll find sample mflex, and let's see the movies collection. We will use this movie collection throughout this lecture. So let's explore it. This is a typical movie document. It has the genre, which is an array. Cast, again, it's an array of strings. Countries, array of strings. Directors, array of strings. Awards, this is an embedded document. IMDb, again, is an embedded document. And tomatoes is an embedded document which have embedded document. Okay. Why are we using this? Because we haven't created a collection that have many records. So instead of creating one, which we'll do later in this course, I'll just query this collection. Okay. But to be able to do this, we will have to create a collection in our Jupyter notebook. So I will create the IMDb class IMDb. This is, as we have seen, an embedded document. Now let's check the fields again. Rating is a float field. Votes is an int field, and ID is an int field. Let's create this. Rating will equal to float field, votes, int field, ID is int field again. Okay, now we need to create the movies class. Of course, we can type all the fields with all the descriptions, but since we will not be using all of these fields, I'll show you any trick. We can create class movies. This will inherit from document. I will need the title, this one, the genres, cast, countries, runtime, and IMDb. Okay, so let's define these. Title will be string field. Genres is a list field of string fields. Cast will be a list field of string field again. Countries will be a list field of string field. Runtime is an int field. And finally, IMDb is an embedded document field. Okay. If we are not going to declare all the fields, we have to use a meta keyword called strict equals false. Otherwise, it will generate an error message when we are using the movie collection, because the number of fields here is not equal to the number of fields here. Okay, so we have to use this strict equals false. Okay, so let's start by querying how many objects in the database. I'll use movies dot object dot count, and it had returned the total number of movies in the database. This is the exact number of record, 23,530. Okay, so let's select the countries that have the USA as its country. So movies dot objects where countries equals USA dot count. This had returned 11,846, but I want to iterate over some of them, so I can just declare a variable movies equal to movies dot objects, again countries equals USA. Now for movie, in movies Of course, I will not iterate over the 11,000, so I'll take only the first 10. Print movie dot title, and now it have printed the first 10 titles. Okay, this is the equality operator. We have other operators that we will check right now. So I will just create a table of operators in here, and let's check each and every one of them. Okay, first one is the not equal operator. So let's check movies will equal to movies dot objects where countries. I want to say not equal. So to define an operator other than the equality operator, we will use two underscores and then type the operator name. Not equal equals USA. Now let's type the movies dot count. If you remember, it was the movies that contains USA is 11,846. The movies without USA is 11,684. So let's get the movies that have the run time, again double underscore, less than 50. We can chain other methods dot count. It's objects, sorry for that. Okay, this is the less than. There is less than and equal, greater than and equal, not in, mod, all, size, and exits. Okay, we will use most of them throughout this lecture. So let's check the less than or equal. I'll just copy and paste this, and let's use less than or equal. Again, I'll copy and paste, and we'll use greater than or equal, and you get the idea. Okay, if you want to negate an expression or negate an operator, we can just use not in here. So not greater than or equal to 50, it means that it's less than 50. Okay, let's try this one more time. This time I'll use not greater than 50, and again it have printed the runtime where they are not greater than 50. Okay, so how to access fields inside nested document? For example, how can I query these fields? So we can use movies dot objects where IMDb. If I want to reference a field inside the embedded document of IMDb, I'll use underscore rating underscore greater than or equal. So this is the embedded document name, and this is the field name, and this is the operator name. Greater than 9, and let's assign this to movies. Now let's get the movies dot count. These are 31 movies which have a rating according to the IMDb greater than 9. Let's print them for movie in movies. Print movie dot title and movie dot IMDb dot rating, and it had printed the movie title and the rating. And notice that to access the rating field that is inside an embedded document, we use the dot operator to refer to that field. Okay, so what if we wanted to query items inside a list? For example, the genres or the countries. But let's first check the genre. So let's declare movies will equal to movies dot object where genres, and we will use the in operator, which means that the values inside the genre are either in drama or in crime. For movie in movies, I'll get the first 10 again. Print movie dot genre. Okay, and as you can see, the in operator will get the record which contains either this one or this one or both. Okay, as you can see from the result, it had returned the records that contains either drama or crime or both of them, like this one. Okay, so let's use the other operator that is the reverse of this one, that is called not in, which is 9. Again, we will print the result, and this 9 is the reverse of in, which means not in. Okay, so what if I wanted to return all movies that have both drama and the crime in the same genre? So I can use the operator called all, which means that return all documents that have both drama and crime in the same genre. Let's check this, and it has returned all the documents that have drama and crime. So what if I want drama always to be the first element? What I mean by this is I just want drama to be the first element in an array. To do this, I can just use this syntax. This will get all genres that have drama as the first element. Lists in Python have 0 index, so this is the first element in the array. Okay, so let's also try another operator. What if I wanted all genres that only have size of 3? So let's check this. This will return all genres that have only 3 elements in the array. Okay, now let's shift our focus to other operators. For example, operators that are used for string matching. So, for example, let's get movies where title, for example, exact equals Titanic, or movie in movies, print movie dot title, and there are 3 movies that have the name Titanic exactly as its title. We also have exact, which is case insensitive, because exact is sensitive. So of course this will search for all movies that have Titanic as its title, but its case insensitive, so it will not take into account the capital letters. Okay, so let's copy both of these, paste it in here, and let's find the movies that contain, for example, Robert De Niro. You can type just the first couple of letters. I'll just pick the first 10. Okay, from each operator we will find 2 versions: exact, exact, contain, contains, start with I start with and end with. Okay, so let's use again another operator. I'll just search for movie title starts with, and don't forget the S after start. It starts with, not start. The game, I love this movie. Okay, and again we can use the same operator for ends. Okay, let's search for it. So all movies that have game as the last word will be selected. Okay, so what if I wanted to sort these movies? Because obviously they are not sorted. So I can do this simply by using the order by title. Now let's print them again. And this is sorted by title. Okay, I can also sort them by rating, for example, order by IMDb dot rating, and in here I'll print also the rating, the IMDb dot rating. Let's execute this and execute this, and they are printed ascending. What if I wanted to print them in reverse order? I can just put a minus sign before the field. Let's check that, and they are now descending from. Okay, we can also get a slice of the data. For example, I can just get movies, which will equal movies dot objects. If I return the objects, it will return all movies in the collection. So I want to get the from 15 to 25 for movie in movies print movie dot title. Okay, we have some basic aggregation that we can use. For example, if I wanted, as we have seen previously, I can return the number of movies dot objects dot count. I can also return dot objects dot sum. I can sum the runtime, for example. This is an integer field. I can also return the average rating. For example, I have an average operator, so we can use movies dot objects. I'll select all movies from the countries equals USA dot average by IMDb dot rating, and it seems we have a typo in here. This is countries. Okay, this is the average rating for all the movies that have USA in their countries. We can also get all distinct value, which means that all unique values in the countries, for example. So I can select movies dot objects dot distinct countries. I'll just type the first 10. Okay, when I am searching the database, all the fields are returned in the document. So I can limit this by limiting the number of fields to be returned. For example, let's say that I want to return only movies. Let's say that I want only to return the title and runtime. So I can just use only, and then here I'll just type the fields that I want to select. Run time. Now for movie in movies, let's pick the first 10 because this will return everything. and in here I'll just print the movie dot title, movie dot runtime, and let's print movie dot countries. And since I have specified that I only want the title and the runtime, countries is printing an empty list. Okay, this will limit the number of fields to be returned, because sometimes I don't want to return all the fields in the documents, because it will take some time to return every field in a document. This can be a huge amount of data to be transferred over the wire. Okay, we can also skip certain amount of records. So I declare movies skip. This will equal to movies dot objects dot skip 100, for example. This will skip the first 100. If I used the for loop as we have used it before, it will not return the correct result, so I have to use for movie in movie skip. I cannot use slicing in here. Print movie dot title if, and let's add 1 to I, if I greater than 10 break. This is called movies, not movie. And it had printed, as you can see, this is from movie 0 to movie 10. I skipped 100 record and I printed it in here. If I just use this as we have done before, I just print this, it will not skip the movies. So to skip, you cannot use slicing with skip. Okay, so what if I wanted to have multiple conditions? For example, if I wanted to get the movies that have rating greater than 7 or 8 and the countries have USA. Okay, so to do this, we will have something called queue operator for query from Mongo engine dot query set dot visitor import queue. Now let's get the movies to movies dot objects, where now we can define our selection criteria. I'll use queue where countries equals USA, and queue IMDb again double underscore rating double underscore greater than or equal to 7. Now we have 2 conditions. I can add more for movie in movies. Again, I'll pick the first 10. Print movie dot title and movie dot countries and movie dot imdb dot rating. Okay, all of these movies have USA in the country and the rating is greater than or equal to 7. Okay, so we can also create multiple conditions. For example, let's change this to France and I'll just use an OR operator, or Germany, and rating is greater than or equal 8. So this will pick all the countries that have France or Germany in the list of countries, and the IMDb rating is greater than or equal to 8. Let's execute this. And it had printed all the countries that have France or Germany and its rating is greater than or equal to 8. Okay, this will conclude our lecture. Thank you for watching and join me in the next lecture. Welcome back. In this lecture, we will learn how to update documents. We will import everything from Mongo engine. I'll connect to the local server and create test DB. Now let's create class student, which will inherit from document. We will have first name, string field, last name, string field, email will be an email field, age will be an int field, courses, this will be a list field of string field, and finally phone will be string field. Okay, now let's create a couple of students. I'll create student 1. This will be an instance of student, which will have first name John, last name Dark, email j.dark@yahoo.com, age will be 16, courses will be a list of math and science, for example, and finally phone will be a string value 5056464. Okay, now let's save student 1. Okay, let's check campus. Test DB had been created and it includes the student. The student have the courses array which contain string objects. Okay, to update a document, first we need to search for it. So for example, I will create student 1, which will be student.object, and I'll search for email will equal to j.dark@yahoo.com. Now student 1 is a record set that have a single record. I can update. I have multiple methods, update and update 1. I will use update 1. We have a couple of parameters that we will learn in this lecture. We have the set parameter. Set will set the value of a field to a certain value, for example 0, 1, 2, 3, 4, 5, 6. 1 means it have updated the field correctly, so 0, 1, 2, 3, 4, 5, 6. I also have student.update. Let's use update this time. I will unset underscore phone equals 1. Let's check what this will do. It will completely remove the field. Unset will remove the field. So let's add the phone again. We have also a parameter called increment. Increment, for example, the age by 1. The age that we have inserted first was 16. Now after the increment, let's check the value of the age. It's 17 now. You can increment it by another value. For example, if we increment it by 10, it will be now 27. Okay, we have also a parameter called decrement, so we can, instead of increment, we will use decrement, DEC. I'll just decrement it by 11, and now we will go back to the 16. We can also add element to an array. For example, I can push, don't forget the double underscore, courses equals history. And now this is the old value that does not have history. If we refresh this, let's check. Now it have history. We have also push all, and this will insert a list. So if I have biology and geology, let's execute this. Let's check campus, and they have been added. To remove an element from this array, you can use pop courses, which will, this should be double underscore. Let's refresh, and now it have removed the last element. I can also remove certain item from the array by using pull. Update is similar to update one, except update will update all the records that match this criteria. And since we have only one record in our query set, it will update this record specifically. But if I have multiple records, it will update all the records. Update one, if it's working on a query set, it will update only the first record. Okay, so again, let's continue. We have pull courses double underscore courses, and I will remove history. Now let's check campus. Okay, I also have pull all, which will similarly remove an entire list. Math and science, for example. Let's check this. Math and science are the first two elements in the list, and now they have been removed. Okay, we have also another operator called add to set, and this will add an element to the array if it does not exist. So right now we have only biology, so let's add math, for example. Okay, let's refresh, and now it has biology and math. If I executed this again, let's refresh, it did not add anything because math is already exist. Okay, remember that when we searched for the student, we used the email. So let's modify this email. I'll use student1.update email will equal to j2.dark@yahoo.com. Now the email is modified. Let's update the phone. For example, this will be 0987654. If we executed this, it will not work. Why? Because student 1 now is pointing to something else. So we should again get student.object where email equals j2.dark@yahoo.com. and now if we executed this, it will work. Okay, be aware that if you updated the field that the object is pointing to, you have to get again the object in order to continue updating. Okay, one last thing, you could have used student2, for example, which will be student.objects of email equals to j2.dark@yahoo.com. First, because this will return, without the first it will return a query set, but we want to retrieve the object itself. I could use student2.courses, which would equal to math, science, and history. And in this case, I have to use the save method. Let's check this. Now it have updated the record. Okay, this will conclude our lecture. Thank you for watching and join me in the next lecture. Welcome back. In this lecture, we will learn how to delete documents. We will import everything from Mongo engine and we will connect to the test DB. I'll just drop this test DB and we will create all the objects again. Now let's create class student, and this will inherit from document. First name will equal to string field. I'll just copy and paste this a couple of times. Okay, last name, this will be an email field. Age will be an int field. Courses, which will be a list field of string field. And finally, phone will be string field again. Okay, now let's create a student, student1. This will be an instance of a student. This will have first name Jack, last name Brown, email j.brown@hotmail.com, age 19, courses will be math and science, and finally phone will be 01235. Okay, now let's save this. Okay, let's check Compass. Now we have created student 1. Okay, again, to be able to delete an object, you can use student1.delete, but I'll assume that you have created the records first and then you have to search for a record. So I'll use student.object where the email equals j.brown@mail.com. This time I can use .delete. Let's check this. It have deleted the record. So let's create another student. Again, I will copy this and paste it. Now let's check Compass. We have a record created in here, and I can always use student.drop collection, which will drop the entire collection. Now let's check this. Okay, let's refresh. It have deleted the collection, and since this was the only collection in the database, it have removed the test DB. Okay, this will conclude our lecture. Thank you for watching and join me in the next lecture.